Okay, hey, so this video is going to be about how to balance chemical equations, okay? So in the past lecture and in class, we talked about the fact that if we don't have the same amount of atoms on the reactant side as we do the product side, our reaction is not balanced, therefore it is not a chemical reaction. Okay, so in order to offset this, we are going to learn how to balance chemical reactions in order to make them actually mean something to us, okay? And we do this because the law of conservation of matter, it states that in a chemical reaction, matter is neither created nor destroyed, okay? A balanced chemical equation has the same number of atoms on each side of the arrow, and this is going to fulfill the law of conservation of matter, and that's why we have to do it. So, how do we do it? To write a balanced chemical equation, first it's important to note that when we write a balanced chemical equation, we cannot change the composition of the substance itself. Meaning, if I have something like H2O, which is water, let's say I'm trying to make 2 oxygens, I can't put a 2 here, because now I'm going from water to hydrogen peroxide, and those two things aren't the same, okay? So I don't do this, but what I do have to do is put a 2 out front, which now indicates that I now have 2 oxygens, okay? So to balance, we're changing the coefficients, these numbers out front, not the subscripts, okay? Now, in general, I like to follow these 3 basic guidelines, and these really help me when it comes to balanced chemical equations, okay? So the first thing I always do is I look for elements that are written by themselves, and I'm going to balance those last. Anything that shows up more than something else in the chemical reaction, I'm going to balance that second last. And then I just move from, well, for you, it would be from left to right, counting the atoms and using coefficients to balance. Okay, so let's look at some examples here. So I have carbon plus oxygen gas, and I'm creating CO2. First question is this balanced? Okay, so we're just going to count like we've been doing before. I like to sometimes draw a big line here indicating that this side has to be equal to this side. So I'm going to say 1 carbon, that's good. 2 oxygens, that's good. Therefore, this is balanced, okay? Now the next part, let's skip this part. The next part here, we've already have it drawn, is we can then say that I have 3 atoms on the reactant side and 3 atoms on the product side, so the law of conservation of matter is being abided by. Now, law of conservation of mass just would be the masses from the periodic table. So I would have 12.01 plus 32, which is oxygen, so this would be 44.01 grams on the reactant side. And I also have 44.01 grams on the product side, therefore mass is also conserved. Okay, now that one was easy because it was already balanced. What about if I don't have something that's balanced? Let's look at the next reaction. Okay, we have H2 plus O2, and I'm creating H2O water. So first question, is this balanced? So let's look here. So I have 2 hydrogens, so hydrogen's balanced. However, I have 2 oxygens here, but 1 oxygen here. Now, like I said before, I cannot put a 2 here to make it balanced. So what I have to do is put a 2 coefficient out front, and now I have 2 oxygens. However, so if I was to draw an image, this is basically what I have, right? But what did I just do to hydrogen, right? So now, since I put a 2 out front, I now have 2 water molecules, which means I now have 4 atoms of hydrogen, which means I'm going to have to double this guy. So I'm going to have to put a 2 out front here. So that means that I now have 2 hydrogen atoms and 1 oxygen atom, and everything is balanced. So it wasn't balanced before, but it is balanced now. And I balanced it by putting 2 coefficients out front, okay? And I can always count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2, okay? So the law of conservation of matter, does it work out? Yes, there's 6 atoms here 6 atoms here. Same thing with mass. So let me write that. 6 atoms. 6 atoms. And then here, if I was to add these up, this would be 4 times 1.01, which is equal to 4.04, plus 32. So I would get 36.04, and then 18 times 18 is 36.04. So mass is also conserved. Okay, now down here, we don't have the nice little pictures that we did before. Okay, so let's look at how we're going to do this. Copper and silver show up by themselves, so we're going to do those guys last. Okay, so I'm going to start with nitrogen and move left to right. Okay, first things first. Let's kind of draw a picture here to see what's kind of going on. Okay, so I have, let's use this guy for silver. Let's use this for nitrogen, and then we'll do the empty guys. 1, 2, 3, 4 oxygen, and then that's copper. Okay, so then over on this side, I have silver by itself. I have copper. Now be careful because there's 2 nitrogens here. So I have 1, 2 nitrogens, and then I have 1, 2, 3, 1, 2, 3 oxygens. Okay? So already we should start to see that this doesn't look balanced just by the picture. Okay, so let's skip silver and copper and do them last because they show up by themselves. Start with nitrogen. So I have 1 nitrogen here, 2 nitrogens here. So how am I going to make this 2 nitrogens? Well, I'm going to put a 2 out front, which now means that I have 2 of these guys. So now here's my other substance, and then here is, oh, I'm sorry. I did it backwards here. I apologize. The 2 needs to go here. So then I have silver here. I'm getting ahead of myself. I apologize. So now I have 2 nitrogens and my 2 nitrogens here. So nitrogen is now balanced. Let's look at oxygen. 2 times 3 is 6. 1, 2, 3, 4, 5, 6 atoms. 2 times 3 is 6. 1, 2, 3, 4, 5, 6 atoms. So oxygen is balanced. Now let's look at silver and copper. Now this 2 out front changed my silvers here, right? Now I have 2 silvers. How many silvers do I have over here? I only have 1. So I need another silver, so I'm going to put a 2 coefficient. And then I have 1 copper here and 1 copper here, which means that's balanced. Therefore, this coefficient is just going to be 1. Sorry, 1. So I don't want to confuse any of you. Okay? So you can ultimately do the same thing. You can say the atoms are equivalent to the atoms on the product side, and the mass is equivalent to the products. And we'll do some of those in class. I'm going to skip the next one. I want to look at this one, which is what we're going to be focusing more on in class, is you're actually going to be given chemical equations, and you have to write the formulas and then balance, okay? So let's look at this guy and how we're going to write this one out. So I have iron 3 chloride, and I'm mixing it with calcium hydroxide, and I'm making iron 3 hydroxide and calcium chloride. So let's write the reactants first. So I have iron, and remember that the 3 goes with the iron. So iron's charge is +3. Chlorine's in group 17, which means its charge is -1. Do the charges cancel? The answer is no, so they have to crisscross. So iron 3 chloride is FeCl3 plus calcium hydroxide. So calcium is in group 2, so its charge is +2. Hydroxide is OH -1. Do the charges cancel? The answer is no, therefore we crisscross. So I'm going to have Ca, but you have to remember, now I have 2 hydroxides, so I have to put in parentheses. So it's going to be CaOH2, and then I'm making iron 3 hydroxide. So again, iron's charge is Fe+3, hydroxide is OH -1, so this is going to be FeOH3 plus calcium chloride. So Ca+2, Cl -1, so CaCl2. and that's my chemical reaction. So, with that being said, you can draw a particle diagram, but let's kind of just look at how we would balance this. So nobody shows up by themselves, and nobody shows up more than anybody else. So I'm just going to move left to right in balancing this chemical equation, starting with iron. So I say, how many irons on this side? There's 1. How many irons on this side? There's 1, so it's balanced. How many chlorines on this side? 3. How many over here? There's 2. So here's something new. I have 3 and 2, so I have to ask myself, what can I make these both into that they can both be multiples of? And the answer to that question is 6, right? Because if I put a 2 here, this becomes 6 chlorines, and if I put a 3 here, this also becomes 6 chlorines. So chlorine is now balanced. However, I just changed my iron. So now I have 2 irons on this side. How many do I still have on this side? Still 1. So I have to put a 2 out front here. Okay? So iron and chlorine are now balanced. Let's look at calcium. How many calciums here? 1. How many calciums here? 3. So I need to put a 3 here. Okay? And now oxygen and hydrogen are last. So I'm going to do 2 times 1 is 2, but then I have this coefficient. So 6 oxygens, 3, 6 oxygens, and then hydrogen is going to be the same. So this substance balanced is 2, 3, 2, 3. Okay? So that's the end for this video. We're going to have tons of practice on this. So if you're still a little rusty with balancing, that's fine. We'll get you caught back up. Thank you.